Out there in the profound obscurity of room, the James Webb Space Telescope has been looking into the obscure for replies about the universe. It's NASA's new eye overhead and has been catching stunning pictures of stars, worlds, furthermore, planets. Yet presently something unforeseen has been found, something so enormous it could shake the actual mainstays of all that we realize. It has researchers scratching their heads and contemplating whether it could prompt the finish of everything. Go along with us as we investigate how the most recent revelation of the James Webb Telescope could annihilate the universe. When we investigate the edge of the universe, our start point, it is the recognizable universe. It resembles a window through which we can look into the tremendousness past. The noticeable universe incorporates all that we can presently recognize, measure, and explore utilizing our telescopes and space tests. It's an assortment of stars, systems, and divine bodies inside our scope of perception. However, the discernible universe is only a negligible fraction of the whole universe. Imagine it as a little cut of a tremendous astronomical pie that we're ready to study and fathom. While the complete size and state of the universe at large stay a secret, researchers gauge the breadth of our noticeable air pocket to be around 93 billion light-years. A light-year measures the distance that light, the quickest thing in the universe, goes in a solitary year, around 5.88 trillion miles or 9.46 trillion kilometers. So at the point when we discuss the distance across of the discernible universe being 93 billion light-years, we're discussing an immeasurable range around 13.8 billion quite a while back. The universe burst into presence in an impossibly strong blast around 13.8 billion years prior. This blast started what we call the infinite extension. Since that groundbreaking birth, the universe hasn't simply been extending. It's been advancing rapidly in its extension. Puzzling forces like the secret of dim energy appear to be driving this speed increase, pushing the limits of the universe farther and farther separated. As the universe extended, matter started to combine under the impact of gravity. This gravitational force united particles, birthing shocking designs. Stars, cosmic systems, and at last planets like our own dear Earth. Picture the eon passing by as these inestimable designs developing into the assorted and stunningness-rousing peculiarities we see dispersed across the universe today. Notwithstanding its tremendous size, the universe is astoundingly void. If we somehow manage to contract down our whole nearby planet group to the size of a quarter, the closest star would in any case be about the length of 2 soccer fields away. This tremendousness extends just inside our own smoothway universe, which is simply one among billions in the noticeable universe, providing us with a feeling of the sheer size of astronomical space. Now you can't help thinking about why we can't just see all that exists in the universe. There are several explanations for this restriction. Right off the bat, light, the quickest thing in the universe, actually takes time to go through space. This implies that when we look at far-off objects, we're basically investigating the past. The farther an object is, the more its light has gone to contact us. It's like looking through a vast time machine, disentangling the historical backdrop of our universe as we notice cosmic systems millions or even billions of light-years away. The universe itself is extending. Imagine specks on the outer layer of an expanding swell. As the inflatable extends, the specks create some distance from one another. This equivalent guideline applies to the universe. Systems, like those specks, are floating separated as the texture of room extends. This development causes the light discharged from far-off objects to go through a change known as redshift. Basically, the frequencies of light become extended as the objects move away, shifting towards longer frequencies, frequently saw as a ruddy tint. Taking into account these variables, light's movement time and the universe's extension, it's not shocking that we haven't yet completely noticed the sum of the universe, even with our generally progressed telescopes and advancements. Our view stays restricted by these fundamental properties of the universe. The mission to grasp the likely edge or limits of the universe has enthralled the personalities of endless people across disciplines. While definitive responses stay slippery, 3 conspicuous hypotheses have arisen, each offering interesting points of view on the boundlessness of infinite space. The first hypothesis suggests that the universe expands endlessly, stretching on without a perceivable end. This idea adjusts with the cosmological standard, stating the isotropy of the universe, its consistency in appearance from any vantage point. In the event that this standard holds, it recommends that the universe comes up short on limit, extending uncertainly on the whole bearings. The subsequent hypothesis offers an elective view, suggesting that while the universe could to be sure be limited, it misses the mark on an obvious edge. Rather, it's like a huge circle or a bended space like a globe. In this situation, if one were to travel perpetually in any course, they would ultimately circle back to their beginning stage, similar as circumnavigating the Earth. The third hypothesis, the multiverse idea, presents an enamoring idea that our universe is only one among various others. Imagine a huge number of equal universes, each existing with its particular arrangement of actual regulations, constants, and properties. These universes may be altogether disengaged from each other, working autonomously. On the other hand, they could be interconnected through complex components, forming an immense and complex multiverse. The James Webb Space Telescope, JWST, remains as a guide of potential enlightening the secrets that cover the enormous starting points. This amazing instrument has an unmatched capacity to disentangle the cryptic past of our universe, permitting us to peer far past what was beforehand possible. The JWST is an innovative wonder planned unequivocally to notice the universe with extraordinary accuracy. Its high-level capacities expand our vision to the earliest snapshots of the universe. As of late, a noteworthy report distributed in the lofty diary Nature divulged the JWST's revelation of 6 titanic cosmic systems going back between 500 million and 700 million years after the enormous detonation. Incredibly, these old cosmic systems surprise everyone, flaunting sizes far more terrific than expected for their initial presence. These surprising discoveries challenge the tried and true way of thinking about the arrangement and development of worlds in the baby universe. What's genuinely stunning about these revelations is the development of these antiquated cosmic systems. As opposed to presumptions, these divine Goliaths display a degree of improvement similar to our 13-billion-year-old smoothway universe. The sheer extent of stars inside the cosmic behemoth outperforms understanding, each boasting a total mass several billion times more noteworthy than our Sun. Astoundingly, one of these universes might actually have a heavenly mass up to 100 billion times that of our own Sun, overshadowing the as-of-now epic size of our smoothway. The JWST's unrivaled capacity to see the universe's secret domains depends on its usage of infrared light, an undetectable range to the natural eye. This unprecedented power empowers the telescope to catch the weak outflow from antiquated stars and worlds, uncovering infinite remainders that have persevered for billions of years. Basically, the JWST capabilities as a period machine, shipping our vision back through the eon, offering a valuable brief look into the universe as it showed up generally 13.5 a long time back. The late disclosure of epic universes, affectionately nicknamed universe breakers, has changed our figuring out. It's likened to changing history, a shocking turn that challenges the vast majority of the models we had made for early universes. At first, we thought worlds framed from humble beginnings, beginning as minuscule groups of stars and residue. They were accepted to develop step by step, filling in size and intricacy over eons. However, the universe breakers broke these thoughts when the James Webb Space Telescope information and its high-resolution pictures disclosed these mammoth systems. These behemoths showed up unexpectedly, nearly as though alluring to be found, perplexing our past getting it of cosmic advancement. Diving further, researchers utilized spectroscopic methods to examine light across differing frequencies. This examination holds the way to disentangling critical subtleties about these mysterious cosmic systems. Subtleties, for example, their arrangement aspects and distance from Earth. It's likened to a vast investigator story, involving light as hints to open the privileged insights of these titanic substances. The momentous discoveries from the James Webb Space Telescope have moved our comprehension of the universe to remarkable levels. This cutting-edge telescope, worked by a global group of space experts, has as of late unveiled a surprising disclosure: the distinguishing proof of the most established and most far-off cosmic systems at any point noticed. These systems transport us back in time to a time when the universe was at a simple part of its ongoing age, existing a simple 400 million years post the huge occasion of the enormous detonation. The James Webb Space Telescope, out in the huge darkness of room, has been chasing replies about the universe. It's NASA's most recent cosmic instrument, catching striking pictures of stars, systems, furthermore, planets. As of late, it made a disclosure so amazing, it could modify our comprehension of the actual universe, leaving researchers confounded and inquisitive about its potential ramifications. When we investigate the universe, we start with the perceptible universe, a window into the vast territory. Past this, the discernible universe incorporates everything we can right now identify with our telescopes and space tests, containing stars, universes, and other divine bodies. However, it's just a little part of the whole universe. Researchers gauge the distance across of our perceptible universe to be around 93 billion light-years. A light-year measures the distance light goes in a year, around 5.88 trillion miles, making the range nearly incredible. Around 13.8 billion years prior, the universe started with the huge explosion, a massively strong blast that begun the astronomical development. From that point forward, the universe has been growing and speeding up, driven by strange powers like dim energy. Matter started to coalesce under gravity, shaping stars, systems, and ultimately planets like Earth. This continuous development shapes the universe's tremendous aspects, permitting us to impression just a negligible part of its wonders. In spite of its massive size, the universe is astoundingly void. For example, if our nearby planet group were the size of a quarter, the closest star would be 2 soccer handles away. This immeasurability is simply inside our smooth-way cosmic system, one of billions in the discernible universe. We can't see everything because of 2 principal factors: the time it takes for light to traverse space and the universe's ceaseless extension. As universes move away from us, their light stretches into longer frequencies, making some objects excessively far off for us to identify. Researchers use units like light-years to gauge these tremendous distances. Our smooth way is around 100,000 light-years wide, and the closest star to the Sun, Proxima Centauri, is 4.24 light-years away. Noticing system billions of light-years far off permits us to think back in time, seeing them as they were billions of years prior. This vast extension additionally intends that our observational cutoff points are ceaselessly pushed, with the universe's speeding up development shaping our comprehension. 3 principal hypotheses endeavor to make sense of the universe's degree. It very well may be limitless, extending unendingly. It could be limited, yet without an unmistakable edge, like a Goliath circle, or our universe could be one of numerous in a multiverse, each with particular actual regulations. These hypotheses, while speculative, flash logical interest and philosophical thought, testing our comprehension of room, limits, and the idea of presence. The James Webb Space Telescope, JWST, has given notable experiences into early universe arrangement, intended to notice the universe with unparalleled accuracy. It as of late found 6 enormous cosmic systems going back between 500 and 700 million years after the huge explosion. These gigantic cosmic systems, surprisingly mature for their age, challenge existing speculations about cosmic development. The JWST's capacity to see the universe's secret domains depends on its infrared abilities, permitting it to see antiquated stars and universes that have existed for billions of years. The disclosure of these universe breakers recommends that early worlds were undeniably more massive and created than recently thought, requiring a reassessment of how we might interpret grandiose development. This startling finding, alongside the likely presence of secret very enormous dark openings, uncovers that the known mass of stars in the universe could be essentially more prominent than we assessed. The JWST has moreover moved how we might interpret the universe through its high-level profound extragalactic overview, JWST. This aggressive program intends to investigate the universe's beginning phases, uncovering almost 100,000 far-off worlds and offering exceptional insights regarding their arrangement and development. Utilizing its close infrared camera and spectrograph, the JWST has given basic redshift estimations, assisting researchers with planning the astronomical scene and comprehend these systems' positions and attributes. The telescope's investigation reaches out to recognizing faint signs from early dark openings, offering bits of knowledge into their development and advancement. Notwithstanding these exceptional disclosures, the unexpected appearance of dark openings in the early universe stays an enticing mystery, inciting progressing research and theory about their beginnings. In an enrapturing disclosure, the JWST as of late caught the Herbig Legend 211 object, a youthful star discharging supersonic planes of matter. This occasion happening during the beginning phases of star arrangement exhibits the telescope's infrared capacities, permitting researchers to look through thick gas and residue to concentrate on youthful star cycles and structures. The JWST has likewise upset how we might interpret exoplanets, utilizing trend-setting innovation to straightforwardly notice these far-off universes. One outstanding perception was of HIP 65426b, a gigantic gas Goliath multiple times the size of Jupiter, found multiple times farther from its star than Earth is from the Sun. By joining pictures from the Hubble Space Telescope and the JWST, cosmologists have made far-reaching perspectives on systems and developed our information on inestimable development. The James Webb Space Telescope's disclosures have decisively progressed our comprehension of the universe, from early system development to the secrets of dark openings and exoplanets. These discoveries challenge existing speculations and welcome us to reevaluate how we might interpret the universe, featuring the telescope's job in enlightening the universe's mysterious history and huge potential.